Hello, welcome to the next installment of Lesson 6.3. Today we're going to focus on graphing square root inequalities. So we're going to take our knowledge about square root functions, how we graph those, and also how we graph inequalities and put the two together and graph them. Now there'll be some minor tweaks to the inequality stuff and for our graphing just to help us, get as accurate of a solution as we possibly can. So let's look at this example here, which is mostly done, and talk about a couple things, and then we'll do a few more examples. So we're asked to graph y less than or equal to the square root of 2x minus 1 plus 2. So we're going to graph the related equation. We're just going to graph y equals square root of 2x minus 1 plus 2. And remember, since the boundary should be included, we have less than or equal to, we're going to have a solid line. So remember, less than and or equal to and greater than or equal to is a solid line. And less than and greater than by themselves is a dashed line. And then we'll have to talk about whether in open and closed circles as well. So we have less than or equal to, greater than or equal to is a closed circle. Less than, greater than is an open circle. Okay, so just keep that in mind. And that open circle is just for the initial dot. All right, so we want to start figuring out where the domain is. What's that first x value going to be? Remember, we take what's under the radical, so we take the radicand, set it equal to 0, and solve for x. 2x minus 1 equals 0, add 1. 2x equals 1, divide by 2, x is a half. And really, we're going to say x is greater than or equal to a half, because that's what's going to keep the radical positive. So that means our domain is going to be x is greater than or equal to 1/2. That's our domain. That also means our y value is going to be, well, it's not going to be 0. What's our y value for our range going to be? It's going to be the plus 2. So that means our first ordered pair is going to be 1/2 and 2. Then from there, pick a few more points to help you plot your points. Say like 1, 2, 3, 4, something like that. Plug those in. And remember how we did that yesterday, or the last video on the when we did that on the calculator, in case you're not watching on a previous day. We put in our equation 2 times, well, we already did a half, so 2 times 1 minus 1. And if you have the old calculators or older graphing calculators, you'll have parentheses. Make sure you close those. The TI-84 pluses, arrow over, so you're not under the radical anymore. Plus 2. Let's see what you get. You get 3. Now I just do second enter, and I go back and I say 2 times 2 minus 1 plus 2 is 3.73. Close enough. Do it again. Second enter, plug in 3, 4.24, and do it one more time. Plug in 4, 4.65. Then we go in and we graph it. Here's 1/2, 2. Then we'll have 1, 3. So that's right there. And we had a closed circle here because it was less than or equal to. These all stay closed circles along here. Let's see, 2 and 3.73, 3 and 4.24, and 4 and 4.65. Okay, so we got enough points. Draw our line. Now, if you look at your note sheet, I think it should be drawn in, this solid line here going straight down. Once you know where you're going to shade, whether you're going to shade below or above, draw in the boundary Yeah, you want to draw that in so you have a definite stopping point. Other books do this. This one does not, for whatever reason. And so if it's a solid line, you make a solid line here. And if it's dashed, well, then you make the whole boundary dashed. Now we just got to figure out where to shade. Remember, we need a test point. Now, we want to pick a test point that is in the domain. So make note of that. Pick test point in the domain. Because if we picked our usual 0, 0, that's going to be outside. It's going to be undefined, which doesn't help us. That doesn't tell us, should we be shading up here? Probably not. Or shading here. Because technically, there's always a chance this boundary could go up. And so we need to pick something that's in the domain. So pick an ordered pair. I usually just pick something on the x-axis here. We could pick a test point of, I don't know, 2, 0 sounds nice, right? So if your test point, I'm going to abbreviate TP. I don't know why that seems a little funnier these days. 2, 0, plug it in. Is 0 less than or equal to the square root of 2 times 2 minus 1 plus 2? Well, we already know that this, when we plug in a 2 for x, is 3.73. So 0 is less than 3.73. It's true, so we shade down here. There we go. And so now we're done with that problem. All right, let's do a couple other examples. Hopefully these will go a little faster. All right, we aren't going to do all of these right now. We'll do a couple, and then I'll have the rest of them posted, so if you want to check your answers, you can. Let's pick a couple. Let's do number 1. Y is less than 2 square root of x. So we know nothing is happening left, right, or up or down shifting wise, correct? Correct. So we have, let's see here, I want to make sure you guys can see it. There we go. So we have no left, right, no vertical, or no horizontal shift, no up and down, no vertical shift. So our first point is at 0, 0. But notice, I made it an open circle. Why did I make it open? Because I had a less than symbol, not a less than or equal to. Now we make our ordered, our table, so we have a bunch of ordered pairs to graph. We know we plug in 0, we get 0. I plug in 1. What's the square root of 1? That is 1. 1 times 2 is 2. I plug in 2. Square root of 2. So you plug that in. 2 times the square root of 2, 2.83. And 3, and we'll plug in 4. So then we go square root of 2 times the square root of 3 is 3.46. And for 4, well, we know what's the square root of 4? It's 2. 2 times 2 is 4. Well, that was nice. That one worked out nicely. So now as we graph, 1, 2, we just can make a little dot. All these dots here, they don't need to be open. All they are just little points to help us connect our line, our curve, really. All right, then we got 2, 2.83. Yes, I don't tend to make those not quite as large as the others. Let's see, 3, 3.46. I think that's right. 1, 2, 3. Yep. And 4, 4. All right, so here we go. But remember, it's got to be a dashed line, or dashed curve, really, I should say. Now, we don't know for sure which way where we need to solve. We're thinking less than, so less than is probably going to be underneath. So we'll probably draw a dashed line down this way to close off our boundary. But let's pick a test point. All right, so we got to have something. Our domain is x is greater than, or equal to 0. Well, let's pick something in that domain. How about 1? And let's make our test point 1, 0. There we go, through the comma. Hopefully you see the comma there. So is 0 less than 2 times the square root of 1? Well, we know when you plug in 1, you get 2. So 0 is less than 2. That is true. So we need to be shading underneath. So we're going to make a little dashed line on the y-axis, and then we shade below. Generally speaking, and I'm saying this generally, when you have a less than, you're going to shade underneath the curve. When you have a greater than, you're going to shade above. So let's do one of those. Let's hop over here to number 2. Let's see if that happens. We have a greater than. So what happens here with this particular problem? Well, we better figure out our domain. X plus 3 equals 0. Subtract 3 from both sides. X equals negative 3. So our domain is x is greater than or equal to negative 3. That means it's shifting left to negative 3. No up and down, nothing out here or in front of it being added or subtracted. So no up, down. So that means when we make our table of values over here, when we plug in negative 3, we generate 0. And then we keep going. Negative 2, negative 1, 0, 1. That will work. I plug in negative 2. So I plug in negative 2 to my problem here. Negative 2 plus 3 is 1. Let's see. Next, we go back. Negative 1 plus 3. Take its square root will be 1.41. Plug in 0. 1.73. And lastly, we plug in 1. What's 1 plus 3? It's 4. Square root of 4 is 2. Now, we've got to plot all these. What kind of circle do I put at negative 3, 0? That's right, it's open. Okay, now, negative 2, 1. A little dot there. Negative 1, 1.41. Yeah, close enough. 0, 1.73. And at 1, 2. So we have a dashed curve again. Now, let's pick a test point. Let's see. We need to pick something that's in our domain, greater than negative 3 for x. I like to pick stuff on the x-axis. All right, now here's a time. We could pick 0, 0 if you wanted. That works. You can pick anything you want. You can pick negative 2. All right, but since we like our test point of 0, 0, let's do that. So is 0 greater than square root of 0 plus 3? Well, we already know from plugging 0 in that we get 1.73. So is 0 greater than 1.73? No, it is not. So that means we don't want to shade where 0, 0 is. So we got to shade up here. And we need to finish off our boundary. So we're going to make it dashed like that. So we finish off that space. You don't want to color too far. That's why we put that boundary in, so we know exactly where to stop. And then you shade up above the curve. And notice that kind of fit. Greater than, we shaded above the curve. But we didn't go past or any smaller than any of the x values in our domain. All right, let's do one more example. Let's do one. Let's actually do number 9. All the way down here at the bottom. I'll post the answers for the other one so you have a chance to practice and see how to solve. But let's do one where you have to do all the different pieces here, okay? So let's take a look. First of all, let's figure out what's happening under the radical. So we're going to take 2x minus 1, set it equal to 0. Add 1 to both sides. Oh, this sounds like our example, doesn't it? Divide both sides by 2. X equals a half, so that means our domain is x greater than or equal to a half. So any x value we're going to plug in is going to got to be 1/2 or larger for this to work. Now, what happens? Where is this graph going to actually start? Does it start at 1/2, 0, or does it shift? We know it's going to shift right to 1/2. And we see here we have a -4. That means it's going to shift down 4. So it goes down to -4. So that means when we make our first ordered pair, we plug in 1/2, our y value is going to be 0, which makes sense, because if this is 0, because 2 times 1/2 is 1, 1 minus 1 is 0. Square root of 0 is 0. 0 times anything is 0, so 0 minus 4 is -4. Why did I write a 0 there? Didn't mean to. I meant to write -4. Sorry. 1/2 -4. Now, let's pick some more points. 1, 2, 3, and 4. All right, let's plug them in. Feel like a Glade commercial. Plug it in, plug it in. And thank you to all of you who just laughed at that. I appreciate that. And if you didn't, oh well, my feelings aren't too badly hurt. All right, we plugged in 1. And we get -2. Go back, take out x being 1 and make it 2. And now we have -0.54. Okay, go back, plug in 3. 0, positive, oops, that should have a negative there, positive 0.47. And, yeah, always watch your negatives there, don't lose them. Lastly, let's come back here, plug in 4, 1.29. Okay, we got enough points, we can make our approximate graph. So 1/2, -4, 2, 3, 4. Made an open circle again, because we have just a less than. Then I've got 1, -2. 2, -0.54, so about there. 3.47, so about there. And 4, 1.29, so about there. Okay. Remember, we're going to make a dashed curve again. Notice this one's rising a little more quickly because we had a vertical stretch. Now the question is, where are we going to shade? We are going to shade wherever our test point tells us to shade. So let's pick something that's in our domain. Remember, our domain, x is greater than or equal to 1/2. So we need to pick an x value. It's nice when we pick something right on the x-axis, right? Because then we have, our y is 0. So how about that one? 1, 2, 3, well, 4, 0. And it's nice if we pick an x value that we've already plugged in for, because then we don't have to solve again. We simply ask the question, is 0 less than 2 times the square root of 2 times 4 minus 1 minus 4? Well, we know when we plug it in that we should get 1.29. So 0 is less than 1.29. So we say that. You kind of do the best you can, drawing a little dashed line there to close off your boundary. And voila, you shade. And there you go. There is another inequality that you've graphed successfully. But you notice all we've done, we took what we did previously with the square root functions for how to graph that. That's all this part. How does it shift? What's its domain? All that kind of stuff. And then we applied what we know about graphing inequalities with the open and closed circle and the solid and the dashed lines and where we shade from previous learning. So we're putting it all together. And now you guys are going to have a chance to practice. So, happy practicing!